and have a nice day to everyone. Today, I am Dr. Siti Roslinda Yaziz from Center for Mathematical Sciences, UMP, will share the topic for Chapter 4 in Econometrics, that is, Valuation of Basic Regression Assumptions. As we know, two previous chapters in this course are focusing on regression model. In this chapter, we want to look at the valuation of assumptions of the regression models that are multicollinearity, autocorrelation, and heteroscedasticity. We go to the multicollinearity topic first. When two independent variables are highly correlated to each other, it leads to the issue of multicollinearity. For example, if x1 and x2 here are correlated to each other, and if their value of correlation consists of value of -1 or 1, we call x1 and x2 are highly correlated to each other. Note that multiple linear regression assumptions that we looked for in the previous chapter consists of the independence variables correct specification, no linear dependence in independence variables, no autocorrelation in model residuals, residual homoscedasticity, and normality of residuals. Therefore, in this topic, we want to tackle this issue. No linear dependence means no multicollinearity in the regression model. Basically, there are three tests used for checking multicollinearity. The first one is by using correlation between the independent variables. To get the value of the correlation, we can use Microsoft Excel by following this step. The concept of Pearson correlation coefficient is applied to check the correlation between xi. The second test is by using tolerance. The formula for tolerance is 1 minus Ri squared, where Ri squared here is the coefficient of determination of a regression of xi on all the other x. A tolerance of less than 0.20 or less than 0.10 indicates a multicollinearity problem in the regression model. The third test is by checking variance inflation factor, VIF. The rule of thumb to use VIF is if VIF greater than 5, the collinearity exists. If no collinearity, means that the value of VIF should be around 1. VIF is more rigorous check collinearity than correlation coefficient. This is the formula for VIF, where Ri squared here is the coefficient of determination of a regression of xi on all other x. Let's say for this model, when we have 3x, x1, x2, x3. So that to get R1 squared, we can obtain it from regressing x1 on x2 and x3. So that we can get this regression equation. Similarly, R2 squared, okay, is obtained from regressing X2 on X1 and X3. Okay, and R3 squared we can get from regressing X3 to X1 and X2. There are four main effects due to multicollinearity in the model of regression for data. The effects are shown here. The first one, variances or standard errors of regression coefficient estimator BI here will be overestimated. This means that BI will be too large. The magnitude of BI may be different from what it is expected. Means that the effect now will affect the value of BI. Okay, the sign of BI may be opposite of what it is expected. And number 4, adding or removing any of independent variable X will produce large changes in the values of remaining BI or their signs. Okay. Basically, there are two solutions for multicollinearity if it is happen in the regression model. The first one is to drop the independent variables that causing the problem. The second solution, that is we recode the form of the X. For example, if X1 and X2 are collinear, we might try to use X1 and the ratio of X2 over X1 instead. Now, let's look at example 4.1. In this example, we want to study whether the multicollinearity exists in the regression model of the data of Adams burger as presented in this table. For this data, sales here is Y, price that is X2, advertising that is X3, and cost here will be X4. Note that in the previous chapter, specifically in chapter 3, multiple linear regression, we put X1 equals to 1. So that for this data, the fitted MLR model can be written as Y hat equals to B1 plus B2x2 plus B3x3 plus B4x4. To test whether the independence variable xi in the data as well as the regression model is multicollinear, we can check it through the 3 tests as discussed before. The first test is by using correlation coefficient for each pair of independent variable. The table of correlation for each pair of xi is shown here, where we can see that price here is X2, Edward that is X3, and cost will be X4. We can get this table using Microsoft Excel via correlation in data analysis tool. The correlation between X2 and X3. X2, this is X3, okay, that is given by this value. By taking the value at 4 decimal places, that is negative 0.2929. This indicates that there is low collinearity exists between x2 and x3. Okay. Similarly, for the correlation between x2 and x4. x2, x4. So we can get the value from this part. Okay. That is, the value is negative 0.4812. Okay. This indicates that there is moderate collinearity between x2 and x4. While to get the correlation between x3 and x4, we can get from this part. Will give us the value of 0.2253 at 4 decimal places. And this value indicates that there is low collinearity between x3 and x4. Note that to identify low, moderate or high of collinearity, we can use Pearson correlation coefficient to identify its category, either that is under low, moderate or high correlation. The next test to check on multicollinearity that are tolerance and VIF. Since there is close relationship between tolerance and VIF, where the formula for tolerance, that is Ti equals to 1 minus Ri squared, and VIF formula, that is 1 over Ti, so that we can analyze them together. Since there are 3 x here, okay, x2, x3 and x4, so that we need to check the collinearity between x2 on x3 and x4. Okay, the second one, x3 on x2 to x4. And the third one, that is we need to check the collinearity between x4 to x3 and x2. Okay, we need to check one by one. So the first one is we check x2 on x3 and x4. So for this case, okay, price here, imagine that price here actually is x2, but when we want to regress x2 on x3 and x4, okay, so now price here, x2 here will be y, okay, and Edward here will be x3, cost here will be x4. Okay, so that the model, the regression model here will be like this. Okay, x2 will be our dependence variable. Okay. So that by using Microsoft Excel, okay, the multiple regression analysis conducted, we can get this regression statistics for this data. Remember that price now is assumed as y. Okay, so to calculate tolerance, okay, tolerance, remember that the value for tolerance, that is 1 minus R1 squared. Since now we focus on the first one, okay, that is price. The first independent variable now is price. So that is 1 minus R1 squared. We can get the value of R1 squared from the regression statistic, okay, that is in the part of R square. So by applying the formula, we can get the value now that is 0.9055 at 4 decimal places. Okay, and we also can calculate VIF value, where VIF value that is equals to 1 over T1. Okay, where T1 here, that is 1 over 0.9055. So we get the value for VIF now, that is 1.1044 at 4 decimal places. So that based on the tolerance and VIF values, where we can see that all the values here is close to 1 or around 1, it indicates that no collinearity exists between the independent variables. Similarly, we repeat the same step to check collinearity for x2 on for x3 on x2 and x4. So that now Edward now will be y. Okay, price will be x2 and cost will be x4, where the regression equation now will be like this. Okay, so based on the regression output, okay, so now tolerance means that now this is to calculate T2, because for the second independence variable, where the second independence variable in this case that is advertising. So to get T2 here, this is equals to 1 minus R2 squared. And to get R2 squared, okay, we can obtain that value from this part. Okay, by taking this value at 4 decimal places and applying T2 formula, we can get the value of tolerance now, that is equals to this value, that is 0.9140 at 4 decimal places. Okay, and to calculate VIF, that is equals to, okay, 1 over T2. That is, we'll get the value 1.0942 at 4 decimal places. So that based on the tolerance and VIF values, where all values here also around 1. Okay, around 1. This indicates that no collinearity exists between the independent variables. Okay, the same step for x4 on x2 and x3. So that in this case, x4 here, okay, we'll assume to be y, where y is dependence variable. Price here, that is x2. Okay, and Edward here will be x3. So that we can get the regression equation by this. Okay, so based on the summary output of the multiple regression analysis for that data, okay, we can get the R square here, the value of R square here actually is the value of R3 squared, because this is for the third independence variable. Okay, so by applying the formula for tolerance, so T3 now will be 1 minus R3 squared. So we will get this value. Okay, so the value is 0.9904 at 4 decimal places. And to calculate VIF, this is equals to 1 over T3. So this is equals to 1.0097 at 4 decimal places. So based on the tolerance and VIF values here, Okay, where all the values here are around 1. So that this indicates that no collinearity exists between the independent variables.